Shaitanirajim. Bismillahirrahmanirrahim. Today we are going to solve some more examples using Laplace transformation. So first example is evaluate 0 to infinity e to the power minus of t cube sine t dt. And second one, evaluate L sine hyperbolic cube to t. So solution, L of t cube sine t is equal to minus 1 to the power 3 d 3 over ds to the power 3 of 1 by s square plus 1. This is equal to d2 over ds2 2s over s square plus 1 square, which is equal to d over ds 2s square plus 1 minus s square into 8 over s square plus 1 whole cube. This is equal to 24s s square minus 1 over s square plus 1 to the power 4. Now implies L t cube sine t is equal to 0 to infinity to the power minus of st t cube sine t dt, which is equal to 24 s square minus 1 over s square plus 1 to the power 4. Putting t s is equal to 1, we get 0 to infinity e to the power minus of t cube sine t dt is equal to 0. This is the required answer. Now second one, we know that sine hyperbolic cube 2t is equal to 1 by 4 sine hyperbolic 6t minus 3 sine hyperbolic 2t, implies L sine hyperbolic cube 2t is equal to 1 by 4 L sine hyperbolic 6t minus 3 by 4 L sine hyperbolic 2t. This is equal to 1 by 4 6 over s square minus 6 square minus 3 by 4 2 by s square minus 4. Therefore, L sine hyperbolic cube 2t is equal to 48 by s square minus 4 s square minus 36. This will be the required answer. The next one, using Laplace transformation, show that 0 to infinity sine t over t dt is equal to pi by 2. Solution, we know that L sine at is equal to a over s square plus a square, and therefore L 1 by t sine at is equal to s to infinity a over s square plus a square ds. This is equal to a into 1 by a tan inverse s by a over the limit s to infinity. This is equal to pi by 2 minus tan inverse s by a, which is equal to cot inverse s by a. But by definition, L 1 by t sine at is equal to 0 to infinity to the power minus of st 1 by t sine at dt. Hence, we have 0 to infinity e to the power minus of st sine at over t dt is equal to cot inverse s by a. Taking a is equal to 1 and s is equal to 0, we get 0 to infinity sine at over t dt is equal to cot inverse 0 is equal to pi by 2, which is the required solution of the given problem. Now the next example, evaluate 0 to infinity t e to the power minus of 2t cosine of t dt using Laplace transformation. Solution, we know that we know that L t cosine t is equal to minus 1 d over ds s over s square plus 1. So by the definition 0 to infinity e to the power minus of st t cosine t dt is equal to minus s square plus 1 into 1 minus s into 2s divided by s square plus 1 whole square. After solving, we get s square minus 1 over s square plus 1 whole square. Putting s is equal to 2 on both sides, we get 0 to infinity e to the power minus of 2t into t cosine t dt is equal to 2 square minus 1 over 2 square plus 1 whole square, which is equal to 3 by 25. Now we are going to study about inverse Laplace transformation. So we have some formulas related to that. So first one, L inverse 1 by S is equal to 1. Second, L inverse 1 by S to the power n plus 1 is equal to T to the power n over factorial n, comma, n is equal to 1, where n is equal to 1, 2, 3 and so on. 3. L inverse 1 by S minus A is equal to e to the power at. Fourth, L inverse 1 by S minus A to the power n plus 1 is equal to e to the power at t to the power n over factorial n, comma, n is equal to 1, 2, 3 up to infinity. Fourth one, L inverse 1 by S square plus A square is equal to 1 by A sine A t. Sixth one, L inverse S over S square plus A square is equal to cosine of at. Seventh one, L inverse 1 by S square minus A square is equal to 1 by A square sine hyperbolic at. Eighth one, L inverse S over S square minus A square is equal to cosine hyperbolic at. Ninth, L inverse 1 by S minus A whole square plus B square is equal to 1 by B e to the power at sine Bt. 10th, L inverse S minus A over S minus A whole square plus B square is equal to e to the power at cosine Bt. 11th, L inverse S over S square plus A square whole square, this is equal to 1 by 2A t sine At. 12th, L inverse 1 by S square plus A square whole square is equal to 1 by 2A cube sine At minus At cosine At. Now we are going to solve some problems related to the inverse Laplace transformation. So first example is s plus 7 over s square plus 25 22s plus 5. Second one, 2s square minus 6s plus 5 over s cube minus 6s square plus 11s minus 6. And third one, 1 by s square minus 5s plus 6. So we are going to solve first problem, number 1. It is given that fs bar is equal to s plus 7 over s square plus 2s plus 5. So first we need to break the numerator as s plus 1 plus 6. We can write this s plus 1 plus 6, and now we are going to write ft is equal to L inverse fs bar is equal to L inverse, just we have taken L inverse both side, s plus 1, and this denominator can be written like this: s plus 1 whole square plus 4 plus 6 over s plus 1 whole square plus 4. Now separate with the help of linearity theorem. We can write L inverse s plus 1 over s plus 1 whole square plus 2 square plus 3 L inverse 2 over s plus 1 whole square plus 2 square. So according to the inverse Laplace formula, we can write e to the power minus t cosine of 2t plus 3 e to the power minus of t sine of 2t, which is the required answer. Now second one, fs bar is equal to 2s square minus 6s plus 5 is divided by s cube minus 6s square plus 11s minus 6. Using partial fraction, we get ft is equal to L inverse fs bar. This is equal to 1 by 2 L inverse 1 by s minus 1 minus L inverse 1 by s minus 2 plus 5 by 2 L inverse 1 by s minus 3. This is equal to 1 by 2 e to the power t minus e to the power 2t plus 5 by 2 e to the power 3t. Now question number 3. L inverse 1 by s minus 1 by s square minus 5s plus 6, which is equal to L inverse 1 by s minus 3 into s minus 2. So after partial fraction, we get L inverse 1 by s minus 3 minus 1 by s minus 2. Using inverse Laplace formula, we get e to the power 3t minus e to the power 2t, which is the required answer. Now we are going to solve some more examples. Find the inverse Laplace transform of, there are three questions. First, s plus 2 over s square minus 4 s plus 13. Second one, s square plus 2s minus 3 over s minus 3s plus 2. And third one, s square over s to the power 4 minus a to the power 4. Solution number 1, fs bar is equal to s plus 2 over s square minus 4s plus 13. Now this can be written as ft is equal to L inverse fs bar is equal to L inverse s minus 2 over s minus 2 whole square plus 3 square plus L inverse 4 over s minus 2 whole square plus 3 square. How can we get this? Just we subtract 2 and add 2. So minus subtracting portion we have taken as minus 2 and 2 add, so it will become 4. And denominator we factorize, we just manipulate this in terms in like this. So answer of this will be e to the power 2t cosine of 3t plus 4 by 3 e to the power 2t sine of 3t. So taking e to the power 2t by 3 common, we get 3 cosine 3t plus 4 sine 3t. Resolving the given expression into partial fraction, we get in second L inverse s square plus 2s minus 3 over s minus 3 s plus 2 is equal to 1 by 2 L inverse 1 by s, 4 by 5 L inverse 1 by s minus 3 minus 3 by 10 L inverse 1 by s plus 2. This is equal to 1 by 2, it will give you 1 plus 4 by 5, this will give you e to the power 3t minus 3 by 10, this will give you e to the power minus of 2t, which is the required solution of the second portion. Now third one, L inverse f s bar is equal to 1 by 2 L inverse 1 by s square plus a square plus 1 by 2 L inverse 1 by s square minus a square. This is equal to 1 by 2a sine of at plus 1 by 2a sine hyperbolic at. So therefore L inverse s square over s square over s square s to the power 4 minus a to the power 4 is equal to 1 by 2a sine of at plus sine hyperbolic a